All right, here's an example where we want to find the derivative and then find the gradient or the slope of the tangent line using that derivative function at the point x equals 2. So our equation, I'm going to rewrite so I have that x moved up to x to the negative 1 power. Now I'm going to go ahead and use my power rule. dy dx. I'm going to bring the 2 down in front and then change that to x to the first. Minus 4, bring down the negative 1, and then subtract to power. Now simplify. Negative 4 times negative 1 is positive 4. And then I'm going to change that x to the negative 2 to a positive power by flipping it down to the denominator. So this is my derivative function, which is also called your gradient function. It allows you to find the slope of any tangent at a point. So if we're asking you to find out at the point x equals 2, what would be its slope, you would let x equal 2 in the derivative function. So replace the x with 2, replace the x with 2, and then simplify it. So 2 times 2 is 4, plus 4 over 4, which is 1. So the slope of the tangent line is 5. Here's another example. It says if we have this function and we find the derivative, what does it mean? So let's find the derivative first. So dy dx, use our power rule. So bring our 2 down in front. Bring our 1 down in front. And then simplify. So we get 6x minus 4. So what does this mean? The dy dx is the gradient or slope function of the original equation. From which the gradient of the tangent at any point on the curve can be found. It also is the instantaneous rate of change of y with respect to x. Here's another example. At what point on the curve for this function does the tangent have a slope of 13? So we first need to find the derivative function. So we're going to use our power rule. And there is our gradient function. Now it says our gradient is 13. So that is our dy dx. And we're going to solve this equation for x. So we're going to subtract 5 from both sides, giving us 8. And then we're going to divide both sides by 4, giving us x equals 2. So when x equals 2, we need to find the y coordinate. So how you find the y coordinate is you need to substitute 2 back into the original equation for x. And then simplify it. And you get 15. So the point is 2 comma 15, where the slope of that tangent line would be 13.